All right, so you should be on page 7 of your packet you got on Friday. All right, so remember last week I said there are some exponents that you do need to know off the top of your head, and your powers of 3 are some of them, at least up to 3 to the 4th power. So does anyone remember what 3 to the 4th power is off the top of their head? It's 81. What's 3 cubed? 27. 3 squared? 3 to the 1st? Now, does anyone remember what 3 to the 0 power is? So I heard ones, I heard zeros. Which one is it? 1. Now, does anyone remember what to do when you have negative exponents? Right, you've essentially moved that base to the denominator. So what do you think 3 to the negative 1 is? 1 over 3. 3 to the negative 2? 1 over 3 to the 2nd power, which is just 1 over what? And it said it twice. Don't know why, but what about 3 cubed? 3 to the negative cube. 1 over 27. What about 3 to the negative 4? 1 over 81. And so, thus, 3 to the negative 77, that's just going to be a huge number that we don't need, but we can rewrite as 3 to the positive 7, d7. So, let me just write it like this. So, in other words, you move it to the other side of the fraction bar. So, if it was originally in the numerator, you move it to the denominator and vice versa. Now, real quickly, look at this right here. So, this is a matter of how you put things in your calculator. What is the difference between this and this? So what do you think the top one will be equal to? So I heard negative 1, I heard 1. What do you think the bottom one would be? The bottom one is flat out 1. But this one is negative 1. Why do you think that is? Parentheses.
Negative is outside of the parentheses.
Right. So the top one is the same thing as this. So it's 3 to the 0 power, which is 1, times a negative 1. Whereas the bottom one is negative 3 to the 0 power, which is just positive 1. So this is true in your calculator. So if you were to put negative 3 squared in your calculator just like that, you would get negative 9. Because they're reading it as 3 squared times negative 1. Whereas if you put negative 3 in parentheses and square it, you get positive 9. All right, so that's true with your calculator, any of your calculators. So please make sure that when you're dealing with negatives and you're squaring them, cubing them, whatever, if you're squaring or cubing or whatever, a negative number, make sure you put parentheses around it. Because otherwise your calculator is going to read it as a negative times the square of that positive number. So in other words, it'll change it to negative. All right. So we just stated this, but anything raised to the 0 power is what? 1. And then negative exponents, what happens to them? So if it was originally in the numerator, where's it going? The denominator. So all it means is that you take everything, including the base, move it to the denominator, or move it to the other side of the fraction bar and make it positive. So this will be 1 over x to the m. Whereas this one, I would move it to the numerator, so it'd be what? X to the positive m. So remember, we don't like negative exponents, so to get rid of it, we just move it to the other side of the fraction bar, and then we can make the negative exponent positive as soon as we move it. Say that again? No. So the negative is only in the exponent. It doesn't apply to the coefficients. The only time that it would apply to the coefficient is if you have a big negative in front of it, like being multiplied to it. That's the only time it would ever count. All right, so let's look at a couple of these. So number 1, how would I simplify it? So we got x to negative 14. So it's going to be 1 over x to the what? Positive 14. We move it to the denominator. What about number 2? Y to the 8th. It gets moved to the numerator, so it's just y to the 8th. What about 3? Positive 27. This will get moved to the numerator, so it's 3 cubed, which is 27. So my rule of thumb, guys, is if it's small enough that you can put in your calculator and not get like some outlandish number, make sure you evaluate the exponent. But if it's like something huge, like 3 to the 77th power, just leave it like that. 4? 1. Anything raised to the 0 power, doesn't matter what it is, it's 1. All right, let's try number 6. So right off the bat, what's one thing that I can just go ahead and kind of... So you can move the x to the negative 2 to the denominator, and it becomes what? Y to the 5th, z to the 0, over x, what? Squared. And then there's one more thing I can do. Simplify the 0 to the 0, which is what? 1. So since it's 1, remember anything times 1 is itself, so we can just kind of cancel that out. So what's my answer? Good. What about number 7? So with number 7, it's kind of however you want to do things. So when it comes to exponent rules, there's really no specific order. It just has to be whatever makes the most sense to you. The only thing that I always recommend with exponent rules is you take care of the power rule first. Besides that, you can do any other kind of simplifying you want in whatever order you want. So looking at this, what's one thing that you guys want me to take care of first? All right, we can go ahead and move the negative to the bottom. So this will be a to the 12th over a to the 5th, b to the 5th, b to the 3rd. Now what can I do? So I heard multiply the b's, which we just add them. This will be a to the 12th over a to the 5th, b to the what? 8. What's the last thing I got to do? So we got to divide the a's, and we do that by doing what to the exponents? Subtracting them. So if I do biggest minus small, it's 12 minus 5, which is what? So where would it go? Numerator, denominator? Numerator. This would be a to the 7th over b to the 8th. Any questions so far? All right. All right, number 8. So be very, very careful when it comes to negative exponents and just multiplying by a negative. All right. This right here does not mean move the negative 2 to the bottom and make it positive. It just means we're multiplying by a negative. Whereas up here, that's actually in the exponent. So really pay attention to where those negatives are. If the negative is not in the exponent, it's considered part of the coefficient. All right. So in reality, what would this be? Negative 2x to the 10th over y to the 13th. Good. And the only reason I'm bringing this up is that I've seen it happen a lot. Now, look at 10 and 11. Very, very similar. All right, but they actually have 2 different answers. So what do you think the answer to 11 is? 1. What do you think the answer to 10 is? 5. Why is it that 10 is 5, but 11 is 1?
Because the 5x is separate from the x, but like the parentheses have them together.
So what would happen right here? What does this look like to us? It's a power rule, which means we would distribute the 0 to both of these. So this would be 5 to the 0 times x to the 0. Both of these are 1. 1 times 1 is 1. But what about number 10? What's the difference? It's only the x that has that 0 applied to it. So this would actually be 5 times 1. The 5 doesn't go away. So again, that's something else you gotta be careful. Just because a variable is raised to the 0 power does not mean it also applies to the coefficient. The only time it does is if it's a power rule. All right. Look at 13. That looks terrible. But in reality, it's really easy. What is it? 1. That's why I always say do the power rule first, because you're applying a 0 to everything. It's just 1. All right, let's do... Yep. Okay, number 9. So, like I said, do power rule first. So if I do the power rule first, 2 would still be raised to the what power? 0 times x to the what? Negative 12. All right, now what do I do? Move the negative 12 to the denominator. So this would be 2 to the 0 over x to the positive 12. And then what's the last thing I got to do? Make the 2 to the 0 1. So this would be 1 over x to the 12. All right, are there any others that you guys want me to do? Or are you guys pretty good? Go ahead, just take the bathroom pass with you.
Thank you.
Mm-hmm. All right, are there any more of these examples that you guys want me to go over? Sure. Okay, so with this one, I would invoke the power rule. So remember, these bases are both raised to the power of 1, so I would apply the negative 3 to both of them. So this would be 2 to the negative 3 over 3 to the negative 3. Now, since they're negative, what do I have to do? Switch them. So this one goes to the denominator, this one goes to the numerator. So this would be 3 cubed over 2 cubed, which, what's 3 cubed? And 2 cubed is 8. And then we just leave it like that. Mm-hmm. So again, what do you guys think I'm going to do first? Power rule. So I'm going to multiply to both bases. So I would now have x raised to the what? Positive 16th over y to the what? Negative 22. So now what do I do? Move the y to the 22 to the top. This is x to the 16th, y to the 22. Okay. So guys, for this one, it doesn't really matter where you start. You just got to start with whatever makes the most sense to you. So where do you want to start? All right, let's do the y's first. So if I handle the y's, what am I doing? You're subtracting them. So big minus small, 8 minus 6, that's 2. Where does it go? Numerator. So this will be y squared over x to the negative 3, x to the 7th. Now, you may think that you need to move that negative, but in reality, what's probably the easiest way so we don't have to do an extra step? Just go ahead and add them together. All right, because if we add negative 3 and 7, what's going to happen? It's going to make a positive exponent. So this would be y squared over x to the 4th. Now, you could have moved the negative 3 to the top and then did the division rule. You just would have ended up with the same thing. So you would have done an extra step. So again, you can do it however you want. I just always recommend doing the power rule first. But besides that, you can do whatever makes the most sense to you. When it comes to exponent rules, there's more than one way to do it. All right. So any questions on the negative rule and the zero power rule? Sure. This will be the last one I do, okay? All right. So same thing, power rule. Both have powers of 1. And since the negative is in the parentheses, I'm assuming it's like a negative 4. All right. So I'm going to multiply the negative 2 to both. So this will be negative 4 to negative 2, x to the negative 2. So they would both get moved to the denominator. So this would be 1 over negative 4 squared, x squared. What's negative 4 squared? Positive 16. So this would be 16x squared. So if that negative is within the parentheses of power rule, assume that it's going to be applied to the coefficient. All right, any other questions? No, because again, this negative is technically not an exponent, it's the coefficient. So another way you could have thought about it was negative 1 times 4 times x all to the negative 2. So if I put that to all of them, that would have been negative 1 to the negative 2 times 4 to the negative 2 times x to the negative 2. And they still would have all got moved to the bottom. So it would have been 1 over negative 1 squared times 4 squared times x squared. So that'll be 1 over 1 times 16 times x squared, which still gives us that. So big negative symbol, it's part of the coefficient. Little negative in the exponent, it's where you actually move it around. Any other questions? All right, now let's look at fractional exponents. So you may remember a little bit of this. I think it's brought up a little bit in Math 1, but it's mostly something new. So we can actually write radicals as exponents. All right. So we talked about this when we did rationalizing denominators, but if you multiply a square root by a square root, what do you get? So in other words, square root times a square root, what is it? You eliminate the square root. So if you have a square root of a number times the square root of the same number, it's just whatever that number is. Because remember, it's the same thing as the square root of 3 all squared. And the square root and the square root cancel out. So same thing with x's. You could rewrite this as square root of x squared. That cancels. Now, they only put like a little negative here, but this is actually negative 1s. So they said 3 to the negative 1 times 3 to the negative 1 is positive 1. Is that true? It would actually be... Oh, wait, no. Those are fraction bars. Never mind. So, when we're adding 1, what two fractions would add up to give you 1 if we're talking multiplication? So, two fractions, they're the same fraction that add to 1. 1/2 and 1/2. So 3 to the 1/2 times 3 to the 1/2. Remember, we just add them, and that gives us 1. Same thing over here. If we add 1/2 and 1/2, that also gives us 1. Well, is it not true that this is the same thing as this? Didn't that give us the exact same answer? Yeah, because 3 to the first is just 3. What about here? Did that give us the exact same answer? Yes, because that's just x. All right. So square roots can be written as an exponent of 1/2. All right. And that is, fractional. So square roots can be rewritten as 1/2. Now, what type of root is this? It's a cube root, which means we're undoing a cube. All right. So if I multiply a cube root to itself 3 times, what happens to it? It cancels out. Because this is the same thing as the cube root of 5 all cubed. And just like how a square undoes a square root, a cube undoes a cube root. So that being said, what fraction do you think, if we added it 3 times, would give us 1? 1/3. Same thing over here. X cubed, the cube root of x multiplied by itself multiple 3 times is just x. It cancels out. Because again, cube root of x, all cubed, cancels each other out. So we would still do 1/3. And just like with the squares, these give us the exact same thing. So a cube root can be written as an exponent of 1/3, and it's still fractional. So here is the fractional exponent rule. All right. If you have, let's say, the b root of x raised to the a power. This is the same thing as the b root of x power rule a power. I'm just showing you the different ways you can see it. And this would be the same thing as x raised to the a over b power. So in other words, whatever type of root you have, that is your denominator. So this would be our denominator in our fraction. And whatever you're raising it to, all right, so whatever power you're raising the base to, that is your numerator. So whether that is in power rule form or it's under the radical with the base, you can see it both ways. That's how you would rewrite a radical as an exponent. Because a lot of times it actually helps to rewrite radicals as exponents. When you get into more advanced maths, so like if you ever take pre-cal or calculus, a lot of times problems become simpler when you take out the square root and change it to a fractional exponent. So some examples here. 16 to the 1/2, that's the same thing as the square root of 16, which is just 4. 27 to the 1/3, same thing as the cube root of 27, which is 3. Negative 8 to the 1/3, same thing as the cube root of negative 8. Now, real quick. So we learned in the last unit that if we square root a negative number, we get an imaginary number. Why is that not true if we cube root something? Because it says it's equal to -2. Why is that not true? So it is true that the cube root of negative 8 is -2. But why is it that it doesn't create an imaginary number? Nope. Think about it logically. If you were to cube -2, so let's say we did the opposite. So if we cubed -2, what's that the same of expanded? So if I expanded this, what would it be? -2 times -2 times -2. So negative times a negative is a positive, but then times another negative is a what? Negative. So this would be -8. So this is true for any odd exponent. Odd exponents, if you have a negative raised to an odd exponent, your answer will still be negative. All right. Even exponents is when you can't have a negative under the radical because there's no way that you can get a negative. So if I did -2 squared, -2 to the 4th, -2 to the 8th, whatever, it would still give me a positive number. But if it's an odd exponent, so -2 cubed, -2 to the 5th, -2 to the 7th, it would give me a negative number. So just a rule of thumb there. So 16 to the 0.25, same thing as 16 to the 4th, which is a 4th root of 16, which is 2. No, because 16 divided by 4 is 4. But remember, it's almost like you're thinking of what number to the 4th power gives you 16, which in this case is 2. Now, if this was like one where you had to evaluate, another way that you can do it is that your calculator will do these special types of roots as well. So in your TI, and if you have it NumWorks, it'll do it as well. But I think that NumWorks, they have like the key like Friend Center. But in a TI, if you want to do any root besides a square root, what you would do is you would hit the math key, which is underneath the alpha key. Now, do you see, if you scroll down, do you see 4 and 5? So number 4 and number 5 on the screen. What's number 4 look like? A cube root. What's 5 look like? Right, any root above 3. So let's say I wanted a cube root. I click 4, I got a cube root. Let's say I wanted to find the cube root of 8. Hit enter, it's there. Now, depending on your calculator, if you want to do any root above 3, you have to put the number first. So let's say I want to do a 4th root. So I'm going to put 4, math, and then I want to hit 5, and now it's a 4th root. Now, depending on how fancy your TI is, sometimes you can hit that 4th root key first before you insert the number. It doesn't really matter. All right, but I know that the ones that I have in the classroom, they have to do that. So you have to put the actual root number first, then hit that key. Let's say I want to do the 16th. Still good too. So just a little calculator trick for y'all. All right, so if I wanted to write this in exponential notation, so in terms of exponents, square root of 6 would be the same thing as what? How would I rewrite that as an exponent? 6 to the 1/2. That's all I need to write. What about the square root of 11x? Be careful about this. So it'd be 11x. We know it's going to be raised to the 1/2, but am I going to I got to put it in parentheses. Why do I need to put it in parentheses? Because it's all under the radical. All right. So in other words, you would have to apply the power rule to it. What about 3? Now, be warned, this is not 2 cubed. This is 2 times the cube root of y. It's just really close together. So how would I rewrite this? 2 times y the what? 1/3. Do I need to put parentheses? No. Because we're only attaching the 1/3 to the y. So remember, there's no parentheses. We're just assuming that the 1/3 is attached to the y only. Now, what if we wanted radical notation? So think about number 4 carefully. So if I have anything raised to the 1/2, what type of radical is that? It's a square root. So I know I'm going to have a square root in there. What's going to go under that radical? So I heard x and I heard 3x. Which one? It's just x. And the 3 is going to go on the outside. Why is the 3 not under the radical as well? There's no parentheses. No parentheses, we got to assume it's only connected to the x. So this one would be the cube root of 4y because it's within the parentheses. So we can apply the power rule. So this would be the same thing as 4 to the 1/3 over y to the 1/3, which we can just put both underneath the radical. What about this one? First off, what type of root do I have? We have a square root. What goes under it? 5mn. Good. So again, just kind of reiterating what I already said with rational exponents. Okay. The base, when it comes to rational exponents, the base is still whatever big value you have that's connected to the exponent of the x. The actual exponent, so whatever that base is raised to the power of, that's your numerator. And your root, so whatever type of root you have, is your denominator. Now, if we're talking radical, a little bit of vocabulary here. The radicand is known as the value underneath the radical. So if I ever say the word radicand, I mean the value underneath the radical. The index is whatever the type of radical is. So in this case, the index is 6 because it's a 6th root. So that little number written outside the radical is known as the index. Now, just to note, if you just see a square root, technically the index is 2. So there's an unspoken baby 2 outside of there. All right, we just never have to write it because square roots are super common. It's almost like if you raise something to the 1 power, it's like the unspoken 1. So if I change these exponents, so I know I'm going to have a radical of some kind. And then something with x. X is raised to the power of what? Well, so in my new value, what's my index? 2. And what's my exponent that's connected with the x still? 1. So if I simplify that a little bit, square root of x. What about the second one? What's my index? 4. So I have a 4th root. And x is still going to be raised to the power of what? 3. All right. What about the last one? What do you think it's going to be? Cube root of x squared. Any questions on that? So again, just to reiterate, if you have x raised to the a over b, that's the same thing as the b root of x to the a power. So it's pretty much the inverse of what we did with the radical exponent rule. And just remember, the denominator of the exponent means the root, whereas the numerator of the exponent means the power. And again, sometimes you may see it like this. All right, it really doesn't matter, but it's the same thing. But this is typically the way I want to see it. So let's look at a couple of these. How would I rewrite x to the 3/2? So what would the root be? It's a square root. We know x is under it. What's the power of x? 3. All right, look at letter B. Before we change it to a radical, what should we do first? We move that negative to the bottom. So we have 1 over y to the 9/8. Now we can rewrite it as a radical, but we're going to leave it in the denominator. So what happens? What does it become? So this would be 1 over the 9th root of y to the 8th. All right. And we're just going to leave it like that. So we don't really need to rationalize that denominator. I know we said we don't like roots in the denominator, but for just simplifying sake, we're just going to leave it like that. What about C? So it'd be a cube root. The 2's on the outside. Why is the 2 on the outside? No parentheses. So x will be the only thing underneath. And what is it raised to? Good. All right. Look at letter D. What type of root is it? It's a cube root. What goes under it? Negative 27 to the second power. Now, we could evaluate this. So, let's say I do negative 27. Make sure you put parentheses around it. And I square it. Tell me if it actually clicked. That'll give me 729. All right, and let's see if that's actually a perfect cube. So math for 729. It is. It's 9. So if I evaluated it, this would be the cube root 729, which is just 9. All right, what about letter F? So everything's in parentheses, which means what happens? Everything goes under the radical. So what type of radical do I have? It's a fourth root, but what else is true about the exponent? It's negative exponent, which means it's going to be moved where? To the denominator. So whatever we do, it's going to be moved to the denominator. So this would be 1 over negative 6m. What type of radical is it? It's a fourth. Was it raised to? Positive 3. Now, if I wanted to clean it up a bit, I could do some more distributing. So I can actually implement this power rule. So this would be 1 over the fourth root of negative 6 cubed, m cubed, which negative 6 cubed is just negative 216. So 1 over the fourth root of negative 216 m cubed. And I'll just leave it like that. Now, if you can get here, I'm pretty happy, but just know that you could simplify that further. All right, last thing and then we're done. So we went from rational to radical. Now we're going to go from radical to rational. So what would letter A be? So numerator is always your what? Whatever your exponent is, whatever the x is raised to. And the denominator is always your what? Whatever the index or the root type is. So x to the 5/4. All right. Look at letter C. So remember, I told you you would see some like this, but still the same thing. All right. So since the negative's under the radical, that means negative x will be included in parentheses. And what's the fraction? Nope. 3 over 7. Because the 3 is what you're raising it to. It's the exponent. And the 7 is the type of root it is. It's the 7th root. Now, this one is a fraction. So we're going to start with 1 over whatever our exponent is. So this will be x raised to the something. What's the fraction? will just be 3, 5. But you are correct. And if I wanted to make it an expression with just a negative exponent, I could move this to the numerator, but make it negative. So it's the same thing as x to the negative 3/5. All right, last one, letter B. Oh, second to last one, actually. All right, so be careful with where the square is. It's right here. So would my negative be included in the parentheses, or would it not be? Not. So we write negative x, and then whatever the exponent is only going to be applied to the x. 2/3. Last one, without even thinking about it. As a negative exponent, because it's in the denominator, what do you think it's going to be? Right. Why is it over 2? It's a square root, so there's an unspoken 2 right here. And it's negative. Good. All right, any questions on any of this? All right, so your homework tonight is pages 11 and 12. And remember, even though there's fractions here, like especially on page 11, the same rules apply. So multiplying, dividing, subtracting, all that good stuff. All right. Also, don't forget that Delta Math from over the weekend. Anything, if you didn't get like the negative exponent parts or anything like that, that is due tonight by midnight. All right, so you guys got a solid 40-ish minutes until class ends. So you can use the rest of this time to work on classwork. Kate, do you want to go ahead and take your quiz? Because this is about the amount of time I gave them on it anyway.
Question about one of the Delta maps that was due like over the weekend. It's not the one that's due today, it was the other one. For some reason, for some of the questions, if you got it wrong, you would just say you got it wrong.
That's weird. I'll double check.
Yeah, so it's saying I have a grade of like 40 or 50. When I did like 80
Oh, no. That's just because I didn't put a late date on it. So, don't worry about it. I can see how much you actually complete, and I do it based on that. All right, Kate. I mean, if you want a second to like look at your. Can I finish my unit 2 test corrections? Yes.